Okay, quick look at, just quick review, our solution set of the final or practice final problems 18 through 21. All right, so let's take a quick look here. On these questions, on the last questions 17, was it, well, no, was it 14 through 17, uh, they were all situations where we were finding sums or differences or simplifying rational functions. And in those cases, to check our problem, we would just plug in a random value of x that's not a zero over the top or the bottom, and then see if we get the same answer before and after. Well, in this case, being as we're actually finding solutions, we're solving an equation, in a way it's easier. We can just plug our solutions back in and see if they work in the original equation to check, which of course we should always do. So what's our strategy here? Well, remember that when we're solving a rational equation, meaning an equation involving fractions, then we're just going to clear all of the fractions by multiplying both sides through, distributing through the least common denominator. Well, what's the least common denominator of 1 and x squared? The smallest thing that they would all divide into. Well, that would just be x squared. So we know that's our LCD, and so now all we have to do is distribute that through both sides. So we end up then with x squared times the quantity 1 plus 12 over x equals negative 27 over x squared times x squared. Remember, I have to distribute it through both sides. I have to treat both sides equally, multiply both sides by x squared because it's an equation. So if I distribute the x squared, I get x squared plus, here I get 12x squared over x. Well, x squared over x simplifies to just 12x. And then on this side, the x squareds would cancel, and I would just get a negative 27. And so what we're left with is a relatively simple equation. There is one thing we need to keep track of, however. Before we clear the fractions, meaning getting rid of the denominators, we do have to look at all the denominators and see what are the values of x that would have to be excluded from our solutions. Because remember, the one unbreakable rule of real numbers is you can't, well, one of two is you can't divide by zero, right? That's never okay. So in both this fraction and this fraction, notice that I'm dividing by a power of x, and so we can't divide by zero, and therefore x cannot equal zero. So we have to remember that. Okay, moving on. If we solve this equation, well, that's a quadratic equation. It's not in standard form yet, though, and we know that's always our first step when we're solving a quadratic equation, is to put it into standard form. So we'll add 27 to both sides, setting it equal to 0. Now it's in standard form. We have options here. If it's easy to do, we'll factor the left side, factor the quadratic trinomial, and you apply the zero product property. Then just find the zeros of the factors that we get, which will be our solutions. And if that didn't work, we would try the quadratic formula. Okay, so this factors pretty easily. Magic numbers that add to 27 and that multiply to 27 and add to 12 would be 9 and 3. And so those give us the zeros, x equals negative 9 and x equals negative 3. So those are our solutions. None of those are excluded, so they should both work. We would, of course, want to check those. And so on the first problem here, I'll go ahead and check them. After this, I won't, just so we can keep this short. But you always should. So if I plug those back in, let's plug in negative 9 and see what we get. If I plug in negative 9, I get 1 plus 12 over negative 9 equals negative 27 over negative 9 squared. So what's that work out to be? 1, that's going to be minus, and that would reduce to 4/3, equals negative 27 over 81. And so on the left side, we end up getting negative 1/3. Is that the same thing as what we get over here? Yeah, it is. If I reduce this, if I divide the top and the bottom by 27, I get negative 1/3, and so that one checks. So that's a good answer. What about negative 3? We'll check that one and see. -3. If I plug that in, I'm going to get 1 plus 12 over -3 on the left, and on the right I'm going to get -27 over -3 squared. We'll just simplify that and call it 9. And so on the left side we get 1 plus -4, so -3, and on the right side -27 over 9 is also -3, so that one checks as well. So -9 and -3 are our solutions. Okay, moving on, next page. Okay, something like this, solve the rational equation, very similar. Okay, what about this? Well, same deal. We've got a rational equation, so we're going to multiply through by the LCD. This time, the smallest thing that would have x as a factor and 1 as a factor and 4x as a factor would be 4x. So then if I want to get 4x on the bottom of everything, let's just take our original equation. And then 1 written as a fraction would just be 1 over 1. So to get a 4x on the bottom of the first fraction, I would just have to multiply both the top and the bottom by 4. Last fraction, to get the 1 over 1, to get a 4x on the bottom, I would have to multiply by 4x and do the same thing to the top and the bottom, and what do we get? Over here we get 4 times 4 is 16 over 4x equals 4 over 4x. Oh, what am I doing? Shoot. Start this again. We're clearing fractions, so I'm just going to multiply through. I don't know what I was adding these things up for some reason. If I just multiply through, my LCD equals 4x, and so we'll just distribute that through both sides of the fraction. So we end up with 4x times 4 over x equals 4 over 4x minus 1 over 1 times 4x. We'll distribute the 4x through the entire thing, through both sides. So on the left side, the x's cancel, and we get 16. On the right side, when we distribute the 4x times 4 over 4x, well, the 4x's in this case would cancel, and I would just get a 4. And then when I distribute to the 1, I just get minus 4x. And so our solution then, if we isolate the 4x, we get, what, if we subtract 4 from both sides? Because we have a single x in this equation, we can just isolate it. So subtract 4, and I get 12 equals -4x. Divide both sides by -4, and we get x equals -3. Do we have any excluded values? Well, if we go back and look in the original equation, we get factors of x on the bottom of 2 fractions, and so once again, x could not equal 0, but our solution was not 0. So we would plug that in and just double check to see that it works, and make sure you do that. I'm not going to, just to save a little time here. Okay, what about this? Solve, they call this a proportion. That's fine. Proportion is just a special kind of rational equation where you have one fraction equal to another fraction, no other terms. The same principle applies as before. We're just going to multiply both sides through by the LCD, which would be, being as we have no common factors, the LCD would be the product of x plus 4 times x minus 6. But remember, there is a great shortcut when we're dealing with a proportion, if we're solving a proportion. All we have to do in that case is cross multiply. So I'm going to get that cross product equal to that cross product. Okay, so what's the green cross product going to be? Well, if I multiply 6 times the quantity x plus 4, and that has to be equal to the yellow cross product, which is 6 times the quantity x minus 6. Well, in this case, what do we end up getting if we distribute? We get 6x, let's make that green, plus 24 equals 6x minus 36. And we could have also just divided each side by 6 if we wanted to. Well, if I subtract 6x away from both sides, look what happens. The 6x's go away and we get the equation, or get the solution 24 equals negative 36, which is false. And so what's that tell us? There are no solutions. And so in this case, we would enter n in Moodle. Okay, let's do, how about if we do one more of those? First, I'll input this answer. So we get n. Oh. Is that the same problem we were doing? Oh no, whoops, we already did that one. There's our problem. Okay, so we got n. Okay, that's the right answer, but let's do another one where the answer is not equal to n. Here's another one, same deal. We've got a proportion, so we could, once again, we could solve this by just cross multiplying. There's a cross product. It would be equal to that cross product. So 15 times the quantity x minus 6 would equal 5 times the quantity x plus 6. And so if we distribute the 15, we'd get 15x minus 90 equals, if we distribute the 5, 5x plus 30, and then we would just solve for x. So in this case, we could just push the x's to the left. We would get a positive number of x's, and the thing is we'll end up with a single x. At the same time, let's push the numbers the other way. So we end up with, on the left, 10x. On the right, we get 120, so dividing by 10, x equals 12. And of course, we could check that by just plugging it in. Okay? All right, so next. Yeah. Solve the rational equation. Okay, this one's, notice there's 2 steps to this one. This is a little harder. You've done a lot like this on the Unit 5, Chapter 9 stuff. So once again, we want to find the factors of the denominators so that we can determine what the LCD is, and while we're at it, we can also figure out what are the values that need to be excluded. I guess we didn't check that on the last one, but if we plug in 12, we should probably go back and take a quick look. Our excluded values in this equation, if we look at the original fractions, we'd end up with, because of the first denominator is x minus 6, we would have to exclude the value 6 from our domain, and the second fraction has an x plus 6 on the bottom, so that 0 would be negative 6, so that's a value that would have to be excluded. But 12 is not either one of those, so 12 is okay. We would still want to plug it back in and check though. All right, okay, back to this problem. So if we write this in factored form, the first fraction is already factored. So we get x plus 3 over x minus 3 equals next fraction, also already factored. Okay, last fraction. Oops. We have to factor. So the last one bottom would factor into numbers that multiply to positive 12 and add to negative 7 would be negative 4 and negative 3. And so we see the smallest product of factors that would include the yellow fraction needs it to include the factor x minus 3. The green fraction needs the product to include the factor x minus 4, and the blue fraction needs both. So it would just be then x minus 3, which takes care of those two factors, times x minus 4, which accommodates those. All right, so if we multiply both sides through by that, what's going to happen? So we're going to distribute that LCD through both sides, which means we're going to have to multiply each term by that. So we'll multiply the yellow fraction by it, we'll multiply the green fraction by it. And we'll multiply the blue fraction by it. Okay, if we do that, we can see lots of cancellation. In the first case, the x minus 3's cancel, leaving us with the product on the top of x plus 3 times x minus 4. We could have probably skipped this middle step by just realizing that when I compare what's on the denominator of the yellow fraction to the factors in the LCD, I can see that the factors that are going to cancel are, oops, what's that doing? Oh, I just can't do that trick. The factors they're going to cancel are x minus 3, which would leave us with the x minus 4 on the top being multiplied by what was already there. Okay, what about the next fraction, the green fraction? Okay, on the green fraction, the x minus 4 is going to cancel top and bottom, leaving me with, on the top, I'm going to have an 8 times an x minus 3. And we could have probably predicted that also, because we see that on the bottom we started off with an x minus 4, which would have canceled the x minus 4 in the LCD, leaving us with an x minus 3 on the top. Then finally we get the blue fraction. Blue fraction, everything cancels except the minus 6 on top. So there's our equation. We have to do a little work on this, but we could distribute everything. We could simplify both sides, combine like terms, set it equal to 0, put it in other words, put it in standard form, and then solve the resulting equation. If I distribute the x through and distribute the 3 through here, I'm going to get x squared plus 3x. If I distribute, oops, I didn't do what I said. If I distribute the x through, we're going to get x squared minus 4x. If I distribute the 3 through, I'm going to get plus 3x minus 12. So if I combine like terms there, I end up with x squared minus x minus 12 equals, and then on the other side it's a little bit easier. I just end up with, if I distribute the 8, I get 8x minus 24 minus 6, and if I combine like terms there, I get 8x minus 30. So if I push everything over to the left to set this equal to 0 and put it in standard form, I end up getting x squared minus 9x, what's that going to be, plus 18 equals 0. So if we solve that by factoring, we can do magic numbers that multiply to positive 18 and add to negative 9 would be negative 6 and negative 3. So we get the solutions x equals 6 or x equals 3. But let's go back up and see if we had any excluded values. Well, if we look at the factors that are in the denominators, those are x minus 3 and x minus 4. So what's that tell us about our domain? Well, that tells us that x cannot equal 3 and x cannot equal 4. So if we're inputting this in Moodle, then we need to include in our list up here of excluded values, we need to include the numbers 3 and 4. And what would our solutions be? Well, we would have to exclude the solution 3 because that's not a legitimate value. That's not a valid value of x. It's not in the domain. So the only keeper in that case is just x equals 6. 3 had already been excluded. Okay, and how, of course, would we check that? We would just plug the x value back up into each of these equations and make sure we get the same thing on both sides. I wouldn't even necessarily have to, let me just show real quick how we could do that numerically too. We could do that numerically by just using a calculator. We of course could do this with fractions. I'll take just a second here and just show you for future reference how you can do this numerically. If I plug in the value 6, what would I get? I would get my first fraction on the left side. I would get 6 plus 3 is 9 over 6 minus 3 is 3. So 9 over 3 is 3. Okay, that's pretty easy. That one. What about the right side? So if we keep track of this, oops. If we keep track of what we're getting on either side then, on the left side we get the value 9. What about the right side? We don't even, you know what, we don't even, this one we just do in our head. We don't even need the calculator. If we plug in 6 up here, we're going to get 8 over 6 minus 4 is 8 over 2. Well, that's 4 minus, and then here we get 6 over, what's the denominator going to be? Well, 6 squared is 36 minus 42 would be negative 6 plus 12 is, negative is 6, right? So we end up with 4 minus 1, which is 3. You know, I think I did that. We don't get 9 on this side, we get 3. Whoops. If I plug in 6, I get 9 over 3 is 3. And so sure enough, we get 3 on the left and 3 on the right. So it does check out. Our solution works. If you got one where we got crazy fractions on the left and the right, well, you could in the future, if you were using even a non-graphing calculator, you could just go through and figure out what the fraction is on the left as a decimal, plug in whatever value you need to for x that you're checking on the right, and get a decimal answer. And if the two decimals match up, then you also, that's a way of checking. Okay? All right. I think that's it for that. Yeah, that's it for that section.